Okay, so we have a picture here of a graph, and it's talking about how efficient cars are. And so in 1955, they were getting so many miles per gallon, like around, looks like about 16 miles per gallon. Anyway, and that stayed pretty good. It went down a little bit, but then it went up, and then they started getting more efficient, right? And it kind of leveled off for a little while, and then it got more efficient up to about almost 2015, and then it looks like it kind of went down again a little bit there. So this is a graph, it's a function, and we can tell certain things about what's happening with this data by looking at that graph. So one thing we can say about functions is they may be increasing and decreasing functions. Increasing means it's going up, this way, and decrease means it's going down that way, okay? So as you read the graph from left to right, so you can see from like 1975 to, about 2014, I would say. So from 2014, from 1975 to 2014, it looks like it was increasing. So the fuel efficiency was increasing. But then it looks like from about 2014, 14 to 2018, looks like it was decreasing. Okay, so we talk about such things. Now, our x-axis is right here. That is the years, okay? We can say, we might talk about it this way, but when we write it in math, we use what's called open intervals. So from the interval from 1975 to, I'm going to say 2014, that is an increasing interval. So we write it in interval notation, but notice that we use the parentheses. Sometimes that confuses students because they're like, well, I'm including that, point. You know what? I guess it's actually increasing from 1970. Let's change it to 1970. It wasn't going up as much, but it was going up, right? Okay, so that's what's going on there. And then it looks like it tops off, though, right there at about 2014. So you could do another open interval. Open just means that you're using the parentheses because you're not including the point where it's actually changing. So from 2014 to 2018, it's decreasing. So let me explain that a little bit more. So at this point right here, where it was kind of a low point, you can't say whether it's increasing or decreasing at that point. It's where it's changing from one to the other. All right, that's why they're open intervals. We can also have a constant function. A constant function is not going up or down. It's just constant. Okay. So here's an example. This might make it a little bit easier to understand. State the intervals on which each function is increasing, decreasing, or constant. So if I look at this first graph, it's coming down. And that's happening from, now notice it was an arrow here. So it's going from negative infinity to 0. It is decreasing. It's going down, right? Sometimes I just put DEC. And then from 0 up to, okay, where's it stopping again? Where's it changing? Up to 2, that is increasing. And then from 2 to infinity, it's decreasing. Now remember, you're reading along the x-axis here from left to right, okay? So you have from negative infinity, there are points like way up there someplace, but from negative infinity up to 0, it was decreasing. And from 0 to 2, it was increasing. But then from 2 to infinity, so from this section here, it was decreasing again. Okay, so hopefully that makes some sense. For B, you've got a line going like this. Oops, not that far though. Stopping right there. So we're saying from negative infinity to 0, because 0 right here, that's where x is being 0 there. That is constant. And then it looks like from 0 to infinity, it is increasing. Okay, so I hope that example helps. It's not real difficult, but it might be a little hard to explain in the video. Either the graph is going up or it's going down. And we're reading left to right. And we're using interval notation.